Speed, distance and time have their own formulas. Let us see how to remember these formulas very easily and accurately in exam. Okay, first draw a y. Okay, now over here, out of speed, distance and time, which quantity generally has larger values in exam or in the question? Distance, because time generally is in second, minutes or hours, so we have 10 hours, 12 hours, something like that maximum. Speed comes out to be 150 kilometers per hour or 200 kilometers per hour, but it doesn't go beyond that. Distances can go up to 500 kilometers, 1000 kilometers, etc. right? So distance quantity generally is seen in a larger amount, so distance is larger, so put it over here at the top. Okay, now speed and time can be written anywhere. You can write speed here, time over here, or you can have even this way, distance here, time here and speed here. Anything is fine, both are same. Let us assume, let us take this one. Okay, so just draw a y and write distance, speed and time. Now let's see what the formulas are. Distance is speed multiplied by time, speed into time. Speed is distance divided by time, d upon t. So what will be time be? Time is nothing but distance divided by speed. Here, see how easily we can remember all the three formulas using a simple y of ds t, right? So in exam, whenever you go for the exam, in the rough at start, just draw this arrow dst, this y, and write this dst over there. So whenever you get a numerical, you can very easily solve it, right? And you will be able to remember the formulas. Now, after the formula, let us move to the types of sums which are asked in speed, distance and time category. Okay, there are generally 4 types of sums. Okay, which is the first category? Distance is same. Second category, speed is same. Third category, time is same. Okay, now these 3 categories, in that no one directly will give that the distance is same or the speed is same or time is same. Whatever the numerical is there, whatever the question is there, you just need to read the question and infer from that whether the distance is same or speed is same or time is same. Okay, and from that you need to solve. We'll try to see the numericals related to these, so it would become easier to understand what we are talking about, right? What exactly do we mean by distance as same? Now there's a 4th type, okay, and that is nothing but average speed. There is no average distance or average time, it is average speed. This concept is there. Okay, now we need to, they might have given that from point A to point B, from point A to point B, a bus is traveling by taking, say, these many stops. Okay, so for the first stop it is traveling for some speed, second stop it is traveling for some speed, third stop it is traveling for some speed and all that stuff. So what is the average speed for the total journey? You don't have to do over here nothing, you don't have to do anything special over here. We know the formula for speed. What is the formula for speed? Speed is nothing but distance upon time. This is our dst, so speed is nothing but distance upon time. So what is then average speed? Average speed is nothing but total distance upon total time, right? Now how to calculate total distance and total time? Now take the bus, see how much time the bus takes to go from here to here. Okay, that is say T1, then from here to here say it is T2, from here to here it is say T3, okay, till here. Then add all this and you will get total time, right? So you got total time. Now how to get total distance? Again similar way, find the distance between this point and this point, find distance between this point and this point. Again this would be D1, this would be D2, this would be D3 and so on. Simply add these and you will get the total distance. So you have total distance, you have total time, just find out the average speed. Okay, this is average speed. We are going to see sums on average speed, so even if you have not understood it right now over here, while solving the sum, it would become much more clearer. Now let's see the first question. A boy increases his speed to 9/5 times of his original speed. By this, he reaches his school 30 minutes before the usual time. How much time does he takes usually? Now over here, let us see which type of it is, which type of sum this is. This is very easy sum. First we'll write our DST. Okay, then is the speed same over here? No, the speed, the boy increases the speed, right? So speed is not same. Is the time same over here? Speed is not same. Is the time same over here? The boy reaches 30 minutes before the usual time, so time is not same. So is the distance same? Yes. Why? Because boy travels from his home to the school and back to, and again in the second case also the boy travels from home to school or from some place to school. So distance is same, right? So what do we have over here? We have distance as same, that is distance in first case is same as distance in second case, right? What is the formula for distance? From our DST we know S into T, so we write S, speed in first case into time in first case equal to speed in second case into time in second case, right? Because distance is same. Now let us assume that the normal speed or the usual speed of the boy is S. Okay, so S is nothing but the usual speed. This is the usual condition. Okay, this is the usual condition and this is the first condition when the boy is increasing his speed. So if the usual speed is S, okay, then let us assume that with the usual speed S, the boy takes T amount of hours to go to school, right? So the boy takes say t amount of hours or say t amount of minutes, because here they have given he reaches 30 minutes before the usual time. So let us assume that the boy takes t minutes to reach the school usually. So what is the usual condition? Speed is s, time is t. Now they have given that the boy increases the speed to 9 by 5 times of original speed. So second case speed becomes 9 by 5 times of original, that is s, and time taken is 30 minutes before usual time. That means the boy takes 30 minutes less. So time is t minutes minus 30 minutes. Okay, let's solve it. What do we get? S gets cancelled over here. We have 5t equal to 90 minus 9 threes are 27, 270. So we have 270 equal to 4t. So what do we get? T equal to 4 6s are 4 7s are 0.5, 67.5 minutes. So the boy usually takes 67.5 minutes to reach the school. See how easy the sum was. We just used our DST formulas and we just saw from which category the sum is, whether it is distance same, speed same, time same, or whether it is an average speed sum, and we solved it. Similarly, here the distance is same, you can have speed same, we have to do the same thing. Moving on. Question number 2. Ramesh sees a thief at a distance of 80 meters. Ramesh starts chasing the thief who is running at the speed of 5 meters per second. Ramesh is chasing him with the speed of 7 meters per second. How much distance does the thief cover before Ramesh catches him? Again, very easy sum. This is our speed distance time sum. So write DST. Now let's take out what category of sum this is. Now over here, is the speed same? No, both have different speeds. Then the distance, actually no, because the thief is at a distance of 80 meters and then both start running, then Ramesh covers more distance. So distance is not same. Is the time same? Yes, the time is same. Let's see how. Okay, let's see how. This is not an average speed sum, so even that category is gone. So let's check out whether the time is same or not. Here Ramesh is standing and here the thief is standing, right? And the distance over here is 80 meters. Now Ramesh sees the thief and the thief starts running. At the same moment, even Ramesh starts chasing the thief, correct? Now both are running, and let us say at this point, okay, the thief reaches over here and even Ramesh reaches over here and catches the thief. What does that mean? Both of them stopped at the same time. That means both of them started at the same time and both of them stopped at the same time. That means the time taken is same by both of them, or both of them were running for the same amount of time. So what do we have over here? We have time equal to same, time for Ramesh and time for the thief. So speed for Ramesh. So what is the formula for time? Time is nothing but distance upon speed. See how DST is useful. Sometimes we might get confused while solving or write the wrong formula, but referring to DST will always have the right formula. Time is nothing but distance upon speed. Distance traveled by Ramesh upon the speed for Ramesh would be distance traveled by thief upon speed for thief, right? Now what do we know about speed of Ramesh? We know speed of Ramesh is 7 meters per second. What do we know about the speed of thief? We know that is 5. Now over here, take a look. Let us assume that the thief, what we want, how much distance does the thief cover before Ramesh catches him? Let us assume that the thief covers say d meters, okay? D meters. Let us assume that the thief covers d meter distance before Ramesh catches him. Right? Now why do we take meters and not kilometers? Because here speed is given in meters per second. Also the distance between Ramesh and thief is given in meters. So it is much better to have everything in same format of unit. If the speed was given in kilometers per hour, we would assume d kilometers. If the speed is given in meters per second, we will assume d meters. Okay. Let the thief travel d meters before Ramesh catches the thief. How much distance must have Ramesh traveled then? Ramesh must cover this 80 meters plus this d meters. So Ramesh would travel 80 meters plus d meters, whereas the thief will travel only d meters, right? So distance traveled by Ramesh is 80 plus d and distance traveled by the thief is d. Let's solve this over here. What do we get? 5 into 80, 400. Okay, this is 400 plus 5d equal to 7d. So d is nothing but 200 meters. So the thief covers 200 meters before Ramesh catches him. Now this is a very popular kind of sum that is generally asked, that the thief is running and how when would the policeman catch the thief, how much distance does the thief travel. So please pay attention to this sum, okay? And if you have not understood, I'll explain it again, right? DST, time traveled by both of them is same, okay? Because they start at the same point, end at the same point, or stop at the same point. So time is nothing but distance upon speed. Distance traveled by thief, let us assume it is d, and Ramesh has to cover 80 meters plus the d meter. So 80 plus d, and on solving we get d equal to 200 meters, right? So moving on to next question. Question number 3. P, Q and R are in a cycle race of 4,500 meters. P cycles twice as fast as Q. R cycles 1/3 as fast as Q. R completes the race in 45 minutes. Then where was Q from the finishing line when P finished the race? Now this looks like a little bit complicated or a tricky puzzle type sum. but actually it is pretty simple. You get the answer in the first two sentences only, this sentence and this sentence. Rest of the stuff is absolutely not needed. How R cycles 1/3 as fast as Q and all that stuff. Let's see why. Okay, now we have our DST sum, so we'll have our DST. Okay, now over here what they've given, P cycles twice as fast as Q. P cycles twice as fast as Q. That means speed of P is twice the speed of Q. Right? If speed of P is twice the speed of Q. Now what do we know? Now the distance traveled is same over here. If speed that is 4,500 meters because they are running in a race. So if speed of P is twice the speed of Q, that means P will cover double the distance than Q. That means say they are running for 2 hours, let us assume. Okay, then P will cover 2 times more distance than Q. It's common sense. Let's see, if a cyclist is going at the speed of 10 kilometers per hour and another cyclist is going at the speed of 20 kilometers per hour, in 1 hour the first one will cover 10 meters or 10 kilometers and second one would cover 20 kilometers. That is double the distance, right? Speed is double, so distance covered is doubled because time is same, right? So this is pretty common sense. So P would cover twice the distance as Q, right? So distance covered by P is twice the distance covered by Q. That means Q will cover half the distance of P, right? P covers twice the distance of Q. That means Q covers half the distance of P. We take 2 over here. So Q covers half the distance of P. So if P covers 4,500 meters, how much will Q cover? It is simply 4,500 divided by 2 equal to 2250 meters. This is the answer. Let's see how. What they have given. Where was Q from the finishing line when P finished the race? If this is the start line, this is the finish line. Okay. P has finished the race at this point. Now we have to find where was Q. We know that P will cover twice the distance as Q. Correct? So Q will be covering half the distance as P. So Q has to be at the center point, half the distance. So from the finishing line and from the start line, both the distance are same. Okay. So if the total distance is 4,500, Q will be at 2,250. See how easy it was? That is at the center point. Q would be at the center of the track. Okay. Moving on. Question number 4. Ajay and Vijay travel from A to B at 17 km per hour and 19 km per hour respectively. A is 72 kilometers away from B. Vijay reaches B first and returns immediately and meets Ajay at C. Find B to C distance. Again, very easy. Such kind of sums where a person goes at the finish line and comes back again and all that stuff. It is very easy to solve these sums after drawing a line. Okay. What does that mean? Let's see. Let's draw a line. Okay. What is this? This is A. This is B. Distance between that is 72 kilometers. Since it is a sweet distance time, we have our DST, okay, at the right hand corner. Now, what they say, Ajay and Vijay start from here. Ajay starts from here, Vijay starts from here. Both are traveling, right? Ajay has a speed of 17 and Vijay has a speed of 19 kilometers per hour. Now, Vijay goes over here to B, returns back and meets, say, Ajay at this point. This point is C, okay? So, Ajay has reached here, okay? Vijay has come from here, so Ajay moves over here and comes over here. Vijay moves over here and comes back over here. Now, what kind of sum this is? This is not an average speed sum. Out of that, is the speed same? No, 17 and 19. Is the distance same? No, Vijay covers more distance. We can see because Vijay goes fast, touches the finish line and comes back over here. So, distance is not same. So, let us see if time is same. So both of them start together and both of them meet each other at C. That is stop at C. That means the time is same, right? So let's write time is same. What is time for Ajay is same as time for Vijay. What is time? Time is nothing but distance upon speed. Distance upon distance of Ajay upon speed of Ajay. Distance of Vijay upon speed of Vijay. Both these are equal. Now, what do we have to find? We have to find the distance B to C. We do not know the distance. Let us assume B to C distance is X kilometers, right? So how much did Ajay travel? Ajay traveled from point A to C, right? That is 72 minus X kilometers. Total distance is 72 kilometers. And this is X kilometers. So Ajay traveled 72 minus X kilometers. 72 minus X kilometers. Speed of Ajay is 17. Distance traveled by Vijay. Vijay goes 72 kilometers till this point and comes back again X kilometers. So Vijay travels 72 plus X kilometers divided by 19. Let's solve this over here, okay, in this section. So what do we get? We have 19 into 72 minus 19x equal to 17 into 72 plus 17x, right? So we have 19 into 72 minus 17 into 72 equal to 17 plus 19. That would be 36x. Let's take 72 common. We have 72 into 19 minus 17 is 2. That is 36. X 36 2s are x equal to 4 kilometers. So distance between B and C is 4 kilometers. See how easy it was? DST and R 4 types. Using those, we got the answer and the line diagram. Going to question number 5. Surendra travels from home to office by car. with an average speed of 50 kilometers per hour, he is late by 30 minutes. But when he comes with a speed of 60 kilometers per hour, he reaches his office 10 minutes earlier. How far is his office from his home? Now this sum can be solved by two ways. One is our regular method and another one is an easy method. First I'll solve, and since we have already seen 3 to 4 sums by a regular method, first I'll solve by the easy way. Okay, so and after that I'll solve it by a regular method. Since it is our DST sum, we have our DST, speed, distance, time. Okay, now what is the fast method? Let's see. Draw a clock. Okay, draw a clock. Now this is the regular time at which Surendra reaches office. Now whenever he is going at speed of 50 kilometers per hour, he is late by 30 minutes. So what is 30 minutes? 30 minutes is this. Okay, this is 30 minutes, right? Now when he comes with speed of 60, he reaches office 10 minutes earlier. So this is 10 minutes early, right? This is 10 minutes early. Now, what is the difference between these two times, this hand of the clock and this hand of the clock? It is simply this 30 minutes plus this 10 minutes. So 30 plus 10 would be equal to 40 minutes, right? So this is the difference of time. So time 1 minus time 2 is nothing but 40 minutes. So what is time? Time is nothing but distance upon speed. We have seen over here. So what is the distance traveled in first case? D1 speed S1 minus D2 upon speed S2 would be equal to 40 minutes. Minutes, how to convert minutes to hours? Simply divide by 60. 40 by 60 hours. So what is distance traveled by Surendra from home to office? We do not know, that we have to find out. Let us assume that distance between home and office is D. Okay, D kilometers. So D divided by speed in first case is 50 minus again in second case he travels the same distance D divided by speed in second case is 60. 40 upon 60. LCM is say 50 into 60. We get 60D minus 50D equal to 40 upon 60. 60 gets cancelled. What do we have over here? Let's see. We get 10D upon 50 equal to 40. 10 4s are. So D equal to 50 into 4, 200 kilometers. So distance between home and office for Surendra is 200 kilometers. Now let us move to the second method, our regular method. Now is the speed same? No. Is the time same? No, because initially he is 30 minutes late, then he is 10 minutes earlier. So no. Is there a concept of average speed? No. Is the distance same? Yes, because both the cases he travels from home to office. So we have distance equal to distance, right? Since distance equal to distance, that is nothing but speed into time is equal to speed into time. Now, regularly we do not know in how much time Surendra reaches his office. Let us assume that Surendra takes X hours to reach his office, right? So, what will happen over here, since he is taking X hours, speed in first case is 50. What is time in first case? He takes normal time plus he is late by 30 minutes. So, he is taking 30 minutes extra. So, plus 30 minutes, converting minutes into hours, what do we get? 30 upon 60. That would be equal to, what is the speed in first case? Second case, 60. Now, here what happens is that he reaches 10 minutes earlier. So, he is taking 10 minutes less, right? Less. So 10 minutes less, minutes to hours, 10 by 60. Okay, what do we get? Let's solve it over here. We get these zeros get cancelled. We have 5 into 60x, taking the LCM, okay, upon 30 upon 60. That would be equal to 6 into 60x minus 10 upon 60. Cancelling these out, we get 300x plus 150 would be equal to 360x minus 60. So we'll have 210 would be equal to 60x. X would be equal to 7 by 2 hours. Okay, this is the time taken by Surendra normally. Now let us put it into any one of these equations to get the distance. Let us put it into here. Put it into this. What do we get? Distance is nothing but D equal to is nothing but 50 is the speed into time taken is 7 by 2 hours plus 30 upon 60, right? This is 2s are. So distance would be 50 into 7 by 2 plus 1 by 2. That is 50 into 8 by 2 to 4, 54. So D would be equal to again 200 kilometers. So you saw, you got the same answer over here and here. You can go by any method, but for this sum I would suggest go by the first method. So remember this method, normal method, and whenever there is sum of late or coming early or something like that, you can try this method also. But this method works for everything or every sum, right? So be sure and confident about the second method. Moving to question number 6. Rohit drives from his home at a speed of 30 km per hour and reaches his bank 20 minutes late. Then the next day, he increases his speed by 15 km per hour, but still he is late by 8 minutes. How far is this bank from his home? Again, it is similar to question number 5 or the previous sum which we saw. Let's solve by the fast method. Okay, take a clock. Normally he reaches bank at this time. Okay, he drives at speed of 30 kilometers and he is 20 minutes late. So this is 20 minutes late. Second case, increases speed by 15. So now speed becomes 30 plus 15, 45. Okay, but still he is late by 8 minutes. So he is late by 8 minutes. So this is nothing but 8 minutes. What is the difference between this hand of the clock and this hand of the clock, or the time? That is nothing but 20 minus 8 equal to 12 minutes. So T1 minus T2 is 12 minutes. Since it is DST, we know time is nothing but speed, distance upon speed. So we'll have distance, we do not know. Let us assume distance between bank and home is D, divided by first case speed is 30, minus again second case same distance, speed increases by 15. So 30 plus 15 is 45, equal to 12 minutes. Converted into hours is 12 divided by 60. What do we get over here? We get 30 into 45. We have 45D minus 30D equal to 12 upon 60. 30, this is 2, this is 6. So what do we have over here? We have 15D would be equal to 6 into 45. 15 3s are D equal to 18 kilometers. See how you got it? You'll in exam on practice you will get this answer in hardly 30 to 35 seconds, right? If you practice hard, if you practice enough, under 1 minute you will be able to solve any sum related to speed, distance and time. Moving to next question. Question number 7. Pratik travels 96 kilometers at a speed of 16 kilometers per hour using a bike, 124 kilometers at 31 kilometers per hour by car, and another 105 kilometers at 7 kilometers per hour in horse cart. Then find his average speed for the entire distance traveled. Now, since it is a speed distance time sum, and here we directly see that we have to find average speed. So it is an average speed category. What is the formula for average speed? Normal speed is distance upon time. So average speed is total distance upon total time. What is the total distance? Let us see. First we'll write average speed equal to total distance upon total time. What is the total distance? First he travels 96 kilometers, then he travels 124 kilometers, then he travels 105 kilometers. So what is the total distance? That would be 6, 10, 100, 220, 225, 325 kilometers, right? So this is the total distance traveled. How? What we saw earlier while learning about average speed, if there are two places A and B, and if there are stops in between this, then find this distance, add it with this distance, add it with this distance. Same way, initial 96 kilometers, add it with the second distance. This is 96, this is 124, this is 105. We can do that way, add and add. This becomes total distance. Now how to find total time? Now time is, find out how much time is taken to travel from here to here, this 96 kilometers, then find how much time is taken to travel this 124 kilometers, right? Then find how much time is taken to travel this 105 kilometers. How to do that? Let's see. Total time. Let us assume that initially Pratik travels 96 kilometers at the speed of 16 kilometers per hour. Total time is nothing but time taken for journey by bike, T1, journey by car, that is T2, and journey by horse cart, correct? Because there are 3 types of journeys. So we have to add individual times. What is the formula for time? Time is nothing but distance upon speed. What is the distance traveled in case of bike? 96 kilometers. What is the speed? 16. Then in case of car, distance is 124 kilometers, speed is 31, plus T3, 105 kilometers, that is in case of horse cart, and speed is 7. What is the answer? 16 into 6, 31 into 4, 7 into 7 ones are 7, 35, 15, 6 into 4, 10, 25 hours. Total time taken is 25 hours. So what is the average speed now? Total distance upon total time, that would be 325 upon 25, that would be 25 ones are 25, 75, 13 kilometers per hour. This is the average speed for Pratik. See how we just found out total distance and we found out total time. We divided it, we got the average speed for the entire distance. Going to question number 8. Rohit covers 1/4 of the total distance at 20 kilometers per hour, 1/4 at 10 kilometers per hour, and rest of his journey 80 kilometers per hour. Find Rohit's average speed for the whole distance. This is similar to the previous sum, that is sum number 7. Okay, let's see what it is. We have our DST. This is an average speed sum. Average speed we know is nothing but total distance upon total time. This is derived from what? Speed. Speed is distance upon time. So average speed is total distance upon total time. Let us find out total distance. Do we know the entire distance? Absolutely not. In previous sum, we knew 96 kilometers was given, 124 kilometers was given. So we added it and we got the total distance. Here, do we know total distance? No. So let us assume total distance traveled by Rohit is D. Okay, D kilometers, right? What they are given? 1/4 of the total distance, D by 4, is covered at the speed of 20 kilometers per hour. Next 1/4, D by 4, is covered by 10 kilometers per hour. Rest of the journey. So how much does it remain? How much distance remains? D minus D by 4 minus D by 4, that is D minus D by 2. D by 4 plus D by 4 is D by 2, that is D by 2 distance remains, right? And for it the speed is 80 kilometers per hour, correct? Now what is average speed? total distance upon total time. Total distance we have taken as d. Total time we have to find out. What is total time? Total time is nothing but time taken for the first 1/4 distance plus time taken for the second 1/4 distance and time taken for the rest of his journey. Correct? So there are 3 steps: 1/4, 1/4 and the rest of the journey. So time, individual times when we add, we get the total time. What is this formula for time? Time is nothing but distance upon speed. Distance traveled in the first case is nothing but 1/4, that is d by 4. Right? We have seen over here, and speed is 20. Second case, distance is d by 4, speed is 10. Third case, rest of the journey, distance is d by 2, speed is 80. Okay, so we'll have like this. What do we get over here? D upon 80 plus d upon 40 plus d upon 160. Now, while taking LCM, we see that it is 80, 40 and 160. 160 is the highest number, and 40 and 80 both divide 160. That means 160 is multiple for 40 and 80 both. So 160 becomes LCM. 82s are 160. So 2d we'll have over here. 40 into 4 is 160. So multiply d by 4. We'll have 4d plus 160 into 1. So 1 into d is d. What do we get? 4 plus 2 is 6, 7. 7d upon 160. This is the total time taken. Now, let us find the average speed. What is average speed? Total distance. Assumed d. Total time. 7d upon 160. dd gets cancelled. Average speed is 160 upon 7 kilometers per hour. This is the average speed. I'll write it again over here. Average speed is 160 upon 7 kilometers per hour for Rohit. Moving to question number 9. A walks from Jammu to Delhi, and at the same time B starts walking from Delhi to Jammu. After passing each other, they complete their journeys in 361 hours and 289 hours respectively. Find the ratio of speed of A to that of B. Now over here, our normal method, it would become very difficult and complicated to solve by our normal method. Okay, so here I'm going to teach you a very easy and small formula. It's so easy that once or twice if you just read it, you'll remember it. There's nothing to it. Okay, let's first explain what's going on over here. Let us assume that there are 2 places. Right, one is Jammu and one is Delhi. Now A starts moving from here and B starts moving from here. At the same time, B is going to Jammu, A is going to Delhi. Okay, now let us assume that they both meet at some point over here. Let that point be, say, Shimla. Okay, A and B meet each other at Shimla. Now what they've given is that after meeting each other, A will take, after meeting B, A will take, say, let us assume X amount of hours to reach Delhi. Let us assume X hours. We'll not take these values right now. We'll just take X hours. So after A does not take X hours to travel from Jammu to Delhi. A is taking X hours to travel from Shimla to Delhi. That is, after meeting B, A will take X hours to reach Delhi. Same way, after meeting A, B will take, say, Y hours to reach its own destination, that is Jammu. After meeting A, not the total time taken, right? So speed of A is to speed of B. That is, ratio of speed of A is to B is nothing but root of Y is to root of X. Here you just, this is the formula. Here you just have to remember 2 things. It is not X is to Y, it is Y is to X. Correct? Because this is amount of time taken by B. This is amount of time taken by A. And here speed of A is to speed of B. So here it is time taken by B upon time taken by A. This is for B. This is for A. This is Y. This is X. And here it is A and B. Exactly the opposite. And it is not just XY, it is root of. So just remember 2 things. One is root sign and other is it is exactly opposite, right? It is not the same. It is exactly opposite. It is not the same. So how to solve R sum using this? We know that after meeting B, A will take how much? 361 hours. So X is 361. B will take how much? 289 hours. So what is the ratio of speed of A to B? Speed of A upon speed of B is nothing but, we know, root of Y upon root of X, that is root of 289 upon root of 361. This is nothing but 17's root and this is nothing but 19's root. So the answer is 17 by 19 is the ratio of speed of A and B, right? So see how easy it was. The formula is very easy. You need not, there's nothing complicated over here. Just remember it is the root sign and it is opposite. Whenever such kind of sums come, you can simply use the formula, right? Moving to next question. Question number 10. A car traveling with 5/7 of its actual speed covers 42 kilometers in 1 hour 40 minutes 48 seconds. Find the actual speed of the car. Again, this is very easy. We have our DST. Okay. Now here we have to directly find the speed of the car. We do not know the speed of the car, so let us assume that the speed of the car is S. So right now what they have given actual speed is S. Let us assume actual speed as S. But the car is traveling to 5/7 of the actual speed. So what is the speed with which the car is traveling? 5/7 of S. That is nothing but 5S upon 7. Right? Now here the time is given as 1 hour 40 minutes and 48 seconds. Now converting everything into hours would be complicated. So it's much better to convert it into seconds. So what we'll get, 1 hour is 60 minutes, each minute is 60 seconds, plus 40 minutes is nothing but 40 into 60 seconds plus 48 seconds. That would be 3600 plus 2400 plus 48. That would give us 6048 seconds. Right, so this is the time taken, 6048 seconds. Now distance given is 42 kilometers. Now since we have time in seconds, it's much better to have speed in meters per second or the distance in meters, because again otherwise it would be kilometers and seconds. Everything should be in the same standard. So 42 kilometers is nothing but 42,000 meters. Right, so what do we know? Speed is nothing but distance upon time. Correct. So what is the speed over here? Speed is 57 upon s. Distance is 42,000 divided by what is the time taken? 6048 seconds. Let's calculate. Let's see what do we get. We get 42,000 over here multiplied by 7 divided by 6048 into 5. Okay, 5 8s are 40, 25 4s are 0 0, 7 8s are 56, 44, 7 6s are 42, 28 4. What do we get? 8400 upon 864. Let's divide by 4. 4 2s are 8, 4 1s are 4, 24 6, 4 2s are 8, 4 1s are 4, 0 0. Now here this can be divided by 3. So 3 7s are, 3 2s are, 3 700. We have 700 by 72. This can be divided by 2. We can get 36. We get 350. So we have 350 upon 36 meters per second. Now this is the answer. Now if we want the answer in kilometers per second, just convert this into kilometers per second. How to convert meters per second into kilometers per second? Now whenever we have kilometers per hour, meters per second to kilometers per hour. Whenever we have kilometers per hour and we want meters per second, we simply multiply by 5 upon 18. Okay, we multiply by 5 upon 18. So if we want meters per second to kilometers per hour, we'll divide by 5 by 18. So just divide by 5 by 18. Division by 5 by 18 is nothing but multiplication by 18 by 5. We know this gets reversed, correct? So what do we have? Let's calculate it over here. We'll have 350 upon 36 multiplied by 18 upon 5. This becomes 2. 5 2s are 10. This 10 gets cancelled with this 0. We get 35 kilometers per hour. This is the actual speed of the car. See how easy it was using a very simple formula of DST, and any of the 4 types we can solve any sums related to speed, distance, time. So if you practice more, you will be able to solve the sums within 1 minute. Any sum related to speed, distance, time you will be able to solve within 1 minute for sure.